The final piece of the puzzle when it comes to these solid design principles is the dependency inversion principle, which is a relatively simple concept, and it probably is one of my favorite when it comes to these design principles. And it simply states this, that any sort of class or piece of your application that is dependent upon another piece shouldn't be concerned about the concrete implementations. It should only be interested in the interfaces that that particular class or portion of your application implements. So what does that really look like? Well, if we continue down this invoice printing path, so we have this class here, this invoice printer, and let's say we needed an entire another piece of our application that was some system or some service that's going to be accessible from our application and from other applications that is going to be, its sole purpose is going to be printing. It could be printing invoices, it could be printing bills, or it could be printing just about anything. So let's go ahead and create a new class within our project here. And this is going to be the printing system or service or whatever you'd like to call it. So we'll make this public. And then what we'd want to do is we'd want to say, okay, well, this particular printing system is going to be in charge of printing a number of things. And one of those things it's going to print is going to be invoices. So more than likely, it's going to have some method in here called public void print. And let's say it's going to take in an invoice just like this. And it's going to have some sort of logic here. Well, we already know that we've built an invoice printer that is going to take care of the knowledge of knowing how to print both an invoice, as you see in this version, and a complex invoice, as you see in this one. So maybe one thing we would like to do is maybe hold on to an instance of that particular printer. So we could create a private instance here of our invoice printer. We'll call it underscore invoice printer. And then maybe we will have a constructor here that's going to take in an instance of that invoice printer like this, and then we'll initialize our private variable like that. And so now when we come into our printing system and we want to print an invoice, all we really need to do is call our invoice printer and say we want to print that particular invoice, and then we're on our way. Well, the problem with this is that this begins to limit our printing capabilities, or it's beginning to limit the full-fledged capabilities of this printing system or printing service. The problem with this is that what happens if later on in the future we need to be able to handle another implementation or some other type of printer? Maybe it's going to be, like I said in a previous example, an invoice printer in HTML or in XML or in text or in Excel or some other thing like that that we haven't dreamt of yet. Well, in this case, since we're simply using this implementation, this concrete implementation of the invoice printer, all we know is how to do this particular logic here, which ultimately, if you've worked at any sort of large systems in the past, we're going to get new requirements that are going to need us to extend upon this capability. And if you remember from our interface segregation discussion, we could ultimately begin to add interfaces onto this that's going to enhance this functionality or going to change this functionality ever so slightly. So instead of taking in a concrete implementation of that, what the dependency inversion principle says is any sort of dependency that a system or a class might have shouldn't be concerned with the concrete implementation. It should only be interested in the interface that it implements. So in our case, we're talking about the invoice printer. So now we can change this to only worry about an invoice printer like this. Now you might say, well, that doesn't really change anything. We haven't changed our implementation. We're only changing what's coming in here. But we have, in fact, included or have increased the flexibility of our application. So now, if we have another implementation as opposed to this invoice printer, so let's go ahead and create one. So we'll copy this, and we will create a new instance of a printer here. So we'll say this is invoice printer HTML. And then we'll go ahead and we'll paste this over and we'll fix the class name. So now we have the invoice printer HTML class, which also implements the iInvoice printer, but something that's going to go on in the logic in here is going to contain HTML. So this is going to be in charge of handling all the formatting of these invoices in HTML and outputting them somewhere. We don't necessarily care, but what this does is now, if we were to update our printing system, as you can see here, every time we instantiate the printing system class, we're passing into it an interface or a class that implements an interface of iInvoice printer. So now within our system, we can not only pass in the invoice printer, the kind of main one that we created in the beginning, but we can also pass in this new one that we've created that's going to format things in HTML. We could create another one that handles XML or Excel or any of those types of formats, and this printing system won't care what comes in. As long as it abides by this particular interface, then we're going to get along just fine. So this really starts to become a very good thing for us once again when we start worrying about testing and using mocking frameworks and things of that nature, because now this is much easier for us to test by using dependency injection within our constructor here. So I can create a number of different test implementations of this iInvoice printer interface and be able to test all the methods within this printing system. This also allows us, while we're running our application, to use some sort of dependency injection or IOC container, say like AutoFact or an inject or something along those lines, that can handle getting instances of this particular class based on registrations that we've set up within our application, so we don't have to worry about newing up an instance of a concrete class that implements that interface every single time we want to use this system. We can push that off downstream to have that IOC container do it for us. And these are very good things that you're going to come across once you start to build some of these larger scale projects that you're going to need to create this flexibility in. So that is where the dependency inversion principle comes from, and really allows us to create much more flexible, much more testable applications.